Welcome, everybody, to our next talk, Ransomware Riddle, Untying Cloud Security Mysteries. But first, I want to thank our silver sponsor, Trust on Cloud. Trust on Cloud, accelerate your cloud journey with the right controls. Trust on Cloud provides an exhaustive threat model for cloud providers, Amazon S3, BigQuery, Azure OpenAI, to discover the right controls required to mitigate any identified threats. Trusted by global banks, Fortune 500s, and defense agencies, customers use their product to accelerate their service onboarding and service security assessments and service allow listing processes, which they have found that can reduce time to adopt new cloud services by up to 70%. Additionally, Trust on Cloud allows you to continuously monitor and address gaps in control coverage for your existing services, ensuring you meet your risk appetite and stay current with changes in cloud services. Welcome everybody again to Ransomware Riddle, Untying Cloud Security Mysteries with Pliskin. Take it away.
So let's untie some cloud mysteries. All right, so I will briefly introduce myself. My name is Pliskin. I'm a principal security researcher at Microsoft. I lead a team of talented security researchers that focus on two Microsoft products. The first one is Defender for Cloud, which I hope you are familiar with. It has offerings such as CSPM, Defender for ARM, Kubernetes security, and many others. The second product is Exposure Management, which is Microsoft's effort to expand CSPM beyond the boundaries of the cloud. For example, the hybrid scenarios that was presented here yesterday by folks from Google in their talk, Thinking Outside the Cloud, a CSPM solution cannot present these type of findings to their full extent, and therefore we need an extended management posture solution. In this talk today, we will focus on security graphs, specifically about the importance of getting the edges done right. We will then explore how edges on the graph can bridge between posture management and threat protection. And lastly, contextual correlations. We will see how using the graph we can contextualize alerts. And with this new context, we are able to link singleton alerts that on the surface has nothing in common. We will see how we can fuse them together into an holistic incident. And this body of work has huge potential in enhancing the efficiency of SOCs. All right. So to ensure we are on the same page, we will start with attack path. So attack paths aren't new. In fact, many companies sponsoring this event have an attack path experience in their offerings. At this point, we should just acknowledge that attack paths are built on security graphs. So I think by now, we all realized that attackers understand graphs. They understand the meaning of exploiting trust between nodes. They understand transitive access. And they understand that graphs creates equivalence classes and that the weakest link within a class can bring down the entire class. Attackers understand the notion of traversal. Midnight Blizzard, for example, is an actor who deeply thinks in graph. But not just attackers. Defenders think in graphs as well. Take a look on John Lambert's article from nearly a decade ago. Defenders think in lists, attacker thinks in graphs, and as long as this is true, attackers win. Fortunately, we, as defenders, have started to embrace and implement graph. So in essence, graph is defined by nodes and edges. Nodes represent user, devices, cloud resources, service accounts, service principal, application, and whatnot. Edges represents connections between nodes. For example, role and permissions that were granted to an identity, or secrets found in a node that can be connected to another node. Naturally, security graphs can have additional layers like activities and network traffic, but our focus today is on the crucial role of edges. So let's start with an example. We will have this on-prem device that is running a browser, Chrome in this case. The browser has an open tab with a valid session into Azure. This means that Chrome stores a valid cookie of the user's cloud identity. And presumably, this identity has different permissions to Azure resources. Now, if this on-prem device can be compromised from the outside and the cloud identity has permission to a critical resources, we will call it an attack path. But isn't this modeling feels too dense and too specific? So let's try to generalize it a bit. What about this modeling suggestion? It simplified the previous approach, and we can use it by saying that the on-prem device has credentials of an identity, and this modeling supports loading other credential types that aren't extracted from the browser, right? From PRT, from primary refresh token, from LSAS. Cloud CNI can be found on disk, and NTLM hashes. But there will be times where the machine does not store credentials. In this case, we can analyze its event log to determine who is expected to log in and possibly establish a new edge type. Frequently logged on by. This is a crucial piece of information about this device. So let's assume Bob, who frequently logs into this workstation, has high privilege in Azure. This context implies that the machine could potentially serve as a jump box for a patient attacker. And this is something we would like our SOC to be aware of so they can take this factor into account when they are prioritizing alerts. This is the meaning of bringing posture management to threat protection in terms here of prioritizing alerts. Now, let's augment this approach with a different type of secrets, ones that does not involve an identity node and go directly to the resource. This is how we chose to model it. We are saying that a device contains a secret that enables authentication to another resource. So we have SSH private keys, SQL connection string, kubeconfig files, storage account SAS, and many more. Now, the real elegance with these secrets is not only our ability to efficiently locate them on disks, but also to attribute them to their corresponding resource. And this attribution is actually what drives the edge creation. So, for example, here we can find an SSH private key, and we calculate its public key, and we look for servers that authorize to accept SSH connection using this public key. This is how we can create a new edge, a new connection. So putting it all together, this is the level of richness that we need security graphs to support. And here is another flavor. We replace the on-prem device with a VM that has managed identity assigned to it, and this is another way to obtain tokens from IMDS. So given that we have internalized the depth levels needed to support edge types, let's celebrate the edges that we already have and see how we can utilize them beyond the realm of posture management. So empowering the SOC is the meaning of enhancing the capability of the SOC analyst so we can group together alerts into incidents to ease the alert fatigue of SOC analysts. And another usage, potential usage, is risk prioritization that we can drive using the context that we gather. So let's examine the following case study. We have 3 security alerts, each on a different resource. On the surface, these alerts share nothing in common. Not the IP, not the ISN, not the user agent, not the user account. They are on different resources. And today, products will surface them separately. So let's see if we can enrich the SOC experience here. From correctly modeling the VM node, we can tell whether or not it has a managed identity assigned to it. And here we see that there is a managed identity on a VM1, all right? And if this managed identity has permission to run compute extensions on the Windows node, so we can execute code on the VM2. And basically, compute extension is the Azure tool that allows admin to execute code with local system privileges. And here we can see that the attacker who got access to VM1 was able to run code on VM2. And this is actually the alert that was triggered on VM2. And now on VM2, we can, since we are trying to combine posture with threat protection, and so as part of the posture thing, we are periodically scan the disk for secrets. And we can see that there is a connection string on VM2 that allows access to the SQL servers, to the SQL server. So this is how we can potentially correlate together this entire group of alerts into an attack story that for the SOC analyst, it was taken a lot of work to get it done. And of course, that we are running additional checks before we are surfacing this to customers. But the general notion is, this is the takeaway that I would like you to keep in mind, that we started with 3 different separated alerts that only with the help of CSPM solution we were able to tie together. And in theory, this attack could have been prevented if we had to surface this potential risk as an attack path prior to its compromise. This is, again, how we can leverage posture management for threat protection. So the abstract of this presentation talks about ransomware attack that our team investigated. So this is a good opportunity to acknowledge the support of the team here, specifically Daniel Davrayev and Shai Shavit, who investigated this attack. So generally speaking, the team witnessed that the attacker managed to pivot from on-prem environment to the cloud using a browser cookie of an highly privileged account. It ended with the encryption of SQL servers. And just to ground it a bit more, and for sharing some of our learnings, so the threat actor extracted the cookie from the browser, but once in Azure, they used several compute extensions, which again, as I mentioned earlier, this is the cloud version of LOLBins, of living off the land binaries, that attacker can employ. So here are some links to prior work that we did on the dual use of compute extensions. I recommend reading if you are familiar with them. And last important cloud TTP that should be mentioned as part of this attack is that before the threat actor encrypted the SQL databases, they made sure to delete its cloud recovery backups. And some conclusion. So emphasize that context is everything, and it is our duty of security research teams to keep enhance the variety of edges we support. And second, this augmented context can be applied in other areas as for SOC to cope with alert fatigue, as we demonstrated earlier. And this can also, and I can share that this context that we're gathering is also using to power our product risk prioritization system, which we won't cover today. And I think that's it.
Thank you so much for the presentation. There has been, or there's like a continued effort to try to model this context and model a lot of the interrelationships between cloud resources, and to do so automatically. However, it lacks a bit of that human touch, as you mentioned, or that holistic understanding. Do you, especially with the sense of scale and how a lot of cloud service providers can offer something of this, at least, or it would be nice if they did, I say. Do you have any kind of opinion, I suppose, on how those edges could be better automated, or what tooling could be potentially used or practices could be employed to better enable those edges within any sort of contextual graph or resource graph built for an application or a cloud application?
Just to follow, I understand correctly, I think you can split this question into two. First is about the challenge of modeling, to get this thing right in sustainable approach. And second is about the intimacy level that is required with our resources in order to extract the right artifacts that will allow creation of new edges. I can tell you that both of them are a serious challenge. In terms of getting the modeling right, after we got things wrong, we set up a nice process that kind of combine stakeholders from across different disciplines, where we can discuss whether the customer will understand, whether it will be something that we can be built on, or is it too specific. So this is regarding the modeling piece. And regarding the intimacy level, so every resource has its own set of properties, and this is, I think, a great area of we as community can support each other, and this is why I'm presenting our findings here. And there are actually other great open source tools that also do the same in that sense. So
awesome. We had another question here.
Awesome, great. So I do agree graphs are very important for us defenders as well. I agree that, yeah, we use a lot of lists, and that's pretty much what we're tracking. When you're making your graphs, asset inventory is very big, so are you using Azure AD with on-prem, Microsoft AD in order to create that graph? And then it looked like the solution is to create a new node that is the secret, so almost like a two-factor authentication. Is that the primary solution here, or should it be like access control on initial credentials?
All right. So in terms of CSPM solutions, where we are naturally focused on cloud, we take our asset inventory is basically built from Entra or any other IDP. But it also contains an applications and SPNs that represent these applications and managed identities that are SPNs under the hood. So there are tons of items that need to be considered in order to get the modeling right. In terms of the exposure management, the unified exposure management that Microsoft just released is coming from the same need. The understanding that CSPM has limited its boundary is scoped to cloud. And we know that attacks on cloud don't start on cloud most of the times. So this is where we are going to get other accounts from non-cloud environments. And the artifacts that I just showed, those are artifacts that we are seeing that attackers are using in order to pivot from on-prem to cloud. Specifically, I showed two different approaches of getting the modeling in terms of a secret that can be tied to identity and from the identity, assuming its permission that it has to other resources, or secrets that are bypassing the identity and link directly to the resource. In terms of MFA, I think this would be, whether or not it's enabled or not, enforced or not, challenged or not, I think this can be a property on the AAD account or other version of
Thank you for that. That was like a four-parter question you had there. No, did I see another hand raised? Was there one more? Okay.
Thank you. Great talk. One quick question. Could you give us a sense of the concrete graph parameters of the kinds of graphs that you're talking about? Are they millions of nodes, billions of nodes, millions or billions of edges? Like, what's kind of, I'm trying to just concretize the ideas that you said into the graph's kind of static and dynamic parameters. Are the edges coming and going? Is the graph small world in property or not?
I can give you some numbers. I can share about numbers of Microsoft Corp But I think the main thing here is that I think the graph is still evolving in terms of, so today it's built basically on assets, like the inventory and the edges that we are constantly fighting to enhance. But the graph will reach its, I think, full promise when we will have additional layers of, such as activities, or network topology, network traffic. And I tried to hint to that when I said there is a new edge that we are building that says frequently logged on by. This edge type basically is not configuration-based. We actually go into the disk, extract the event log, look for the event for the logging ID, and we see who is typically using this machine to potentially create a new edge that says, hey, this device may be connected to a user. And now the thing about graph is this equivalence class, because if we say that this identity is critical, like highly critical, right? And it's using this device, this says something about the device. This is the transitive characteristic that the graph allows you. In terms of numbers, maybe we can share it offline.
Yeah, it sounds like a great hallway discussion. Okay, everybody give them a round of applause. Thank you.